All right. Hi, welcome. I invite you all to take a seat. Thank you so much, everyone, for being here today. This talk, along with all talks as part of the speaker series, are hosted by the Data Institute, which is an umbrella organization for all data science and data engineering programming here at the university. Today's a really wonderful day because not only do we have students that are incoming, so cohort 13 here, but we also have other members of our MSDS family. So today, Siang Kong is a senior machine learning engineer at Shipt, and she helps bring groceries to millions of doorsteps. She got her master's degree right here in the USF MSDS program in 2019, so that was what, cohort 7? Cohort 7. And swiftly transitioned into the dynamic realm of data science and machine learning. Siang has etched her mark across the spectrum of cutting-edge machine learning domains, ranging from Bayesian Time Series modeling to search recommendations and crafting language models. During the day, Siang trains LLMs to predict the next best sentence. At night, she tries to predict the next funniest sentence at local improv theaters, which is very cool. Today, she'll be talking about multimodal LLMs, incorporating categorical and continuous features with DistilBERT. So please join me in welcoming Siang.
This? Oh, okay. Hi everyone, I'm Siang, and it's really nice to be back here. It's a very long room. Today I'm going to talk about multimodal DistilBERT classifier, which I realized that I forgot to put on. Sometimes people think of language model as ChatGPT, but today I'm not building ChatGPT. It's a classifier using multimodal LLM, merging categorical and continuous features using DistilBERT. And the agenda today, I'm going to do a little intro about myself and a quick technical overview on BERT, DistilBERT, tokenizers, the mechanisms that you probably know or not know yet. And then I'm going to dive into why multimodal and the model itself and some learnings, my personal learnings, trying to build a model like this. And in the end, we'll come back to visit why multimodal. And the intro, this is about me. I got my bachelor's degree in NTU in econ back in 2016, and I graduated here 19. And then I started doing data science at Third Load, it was a startup, alumnus referral. And I got laid off because of COVID, and I joined Shipt, doing machine learning ever since. I do have a disclaimer here that my company wanted me to state that this talk, it's clear, I'm making it clear that this is not speaking as representative of Shipt or Target, and the information I'm providing in my talk contains no Shipt or Target specific private or protected information. Just so you know, this is very objective information. So I'm not here talking as a senior machine learning engineer at Shipt. I'm here talking as a human, surprisingly. I'm also an improviser. I'm in a duo improv team called Broken Chair. I'm also in an ensemble. It's new, unnamed yet. Has anyone here seen an improv show or know what improv is? Okay, for those who don't, it's like comedy, but it's unscripted. So you have to do a scene. You just kind of have to make things up at the moment. So it's really important to be on the same page with your scene partners because you might be talking about A and they're talking about B, then the scene's not going anywhere. And what's the difference between an improv duo and an improv ensemble? Well, the pros for an improv duo is it's very easy to form, right? You only need 2 people. If you like each other, you can form a duo. And you can always practice together because, there's just 2 of you. And it's very easy to build chemistry and understand how each other play, your playing style. The cons of that, the topics and characters are limited because you only have 2. And when you're stuck, it's very painful to watch. I'm sure some of y'all have seen some really bad improv show. As for an improv ensemble, which means usually more than 3, typically like 8 or 9 people in a team. The pros is there's always new ideas on the stage because you have so many, And you can always have site supports, meaning people can walk on or tag you out or edit. It's much easier to move the scenes together as a group. And the cons of a team, well, there's a lot of people, so it's very difficult to form. It's very difficult to get practice time together. You have to set out poll times and all that. And it's less individual chemistry because you're practicing as a team. So why do we care about this? Why am I talking about this? Because getting confused by language as a human improviser, which is me, I'm also an ESL, so English is not my first language. There's a lot of words that I don't know when I talk to someone. For example, in a scene, my scene partner said to me, "Wow, here comes Nancy Drew." I don't know who Nancy Drew is. I know Nancy Pelosi. That's the only Nancy person I know. But I don't know who Nancy Drew is. For some of you who don't know, she is a fictional detective, a teenager detective character. When I was in a scene with my duo partner and he said, "Oh wow, you're Nancy Drew." To me, that's like, I don't know what to say. I don't know who Nancy Drew is. I don't know what you're expecting from me. So all I can do is, I have to ask him, not specifically who is Nancy Drew, but I have to ask specific questions to get his textual input to help me understand, okay, Nancy Drew is a teenager and she's smart-ish, and I have to play from that. Also, another example might be you're in a scene and your partner said, "Oh, thanks for coming on this date with me in this blimp." I don't know what a blimp is. For some of you who also don't know what a blimp is, it's an air balloon flying machine. But if I was in an ensemble and I was in a scene, somebody said, "Oh, how fun is it for a date in a blimp?" There might be site supports to show like air flowing or there are birds flying around, and I probably would know, okay, we're in the sky. This is probably some kind of aircraft. And what I'm trying to get is, doing an ensemble, you must be wondering, which one is funnier? Or you might not be wondering, but I want to tell you. It depends on the audience and how we define funny, right? Also, improv is not always comedy. There's theatrical improv. Sometimes you're not trying to be funny. And even when you're doing comedy, there's short form, long form. Office is long form improv, and whose line is it anyways? It's short form improv. It's all very different goals you're trying to optimize. Just like machine learning, we need to understand our data and the goal for the project in order for us to know what to use, what vehicle to drive. Is it a classification or a generation problem? Do we need a POC, which is proof of concepts? We just want to whip up something that looks like it would work, or do we need an MVP, which is minimal viable product, which is something that's deployable, right? And now I'm getting into the real topic, which is BERT. I think that you had a talk on transformer, so I didn't spend too much time on transformer. BERT is a type of transformer that's bidirectional encoders representation from transformer. And the difference of BERT and other regular transformers, I don't know if you should call them regular, but it's that it reads the input all at once. It takes a snapshot. It's not doing left to right or right to left, nor left to right plus right to left, because that's kind of like, 2018 language model is all about directions. But BERT, it's not. It's just, it looks at everything all at once. And it is a masked language model, which means it has masks. That masks, look at this example, this is the mask token. It blocks around 15% of the token. So the model is not learning about each token, rather it's learning about the context. It's like when we speak a different language, you're not gonna understand every word in a sentence, but if you can understand like 70 to 90% of it, you're good. You know what they're talking about. And the cons of this great model is that it's a huge model with 200 million plus parameters to download. And your infrastructure team is not gonna like you downloading a whole BERT model all the time to try to play around with, fine tuning. So this is an example of a BERT input token. Do I have to, not yet? Okay. So the input is, my dog is cute. He likes playing. And you can see that this, I circled it here for later. I just want you to pay a little attention on this CLS token at the beginning of the input. My dog is cute. Separator, this means end of sentence. Also means beginning of another sentence, right? Because it's the end of another. He likes playing. And through the tokenizers, we will get tokens for each of these input. And then we encode the sentence, and then the transformer will take these input from here. Yeah, that's it. And because BERT is such a huge model to operate on, there's a very smart variation of that, which is a DistilBERT, and it's called knowledge distillation, which they train the student model to preserve what the teacher model, which is BERT, does. So the student model is not trying to learn from corpus and all that. It's just trying to mimic what BERT as a model could do. This is a picture from, I think it's called the Thousand City in China, where they have all the painters doing all the copying paintings. So it's 40% less parameters, but 60% faster and preserves 95% of the performance. I think it's a very powerful tool to use if you want to build a language model. It's very easy to download. And I want to talk a little bit about the tokenizer. Tokenizers are trained based on the corpus the model is trained on. Like you probably know a little bit about, some learn from Wikipedia, some learn from, CNN newspaper. So each tokenizer would learn word. Most of them learn it byte by byte, which means this sentence here, I have a new GPU. Imagine this being like trillions of words. It would try to find the most common pairing of each word, so I and H and A and V and E, so and so, building up a whole corpus. So they have respective tokens that they learn from each corpus. So in this example, I have a new GPU. This tokenizer thinks I is a word, have is a token, A is a token, U is a token, GPU is not a token. So GP becomes a token itself, and then something U is a token itself, and then the exclamation mark. So this is how tokenizers learn how to make new coming words into tokens, into something that they know, like in their dictionary. You can think of it that way. So here is a more real example of the tokenizer tokenizing. Using a transformer network is simple. The input IDs, 101 is the CLS token that we saw just now. And then these individual token IDs are what these words corresponds to inside the tokenizer dictionary corpus. Yeah, any questions? We can leave your questions too. We're gonna switch out the microphone. Okay, let's take it. Oh, actually, this is a good. Okay, this is a question for you to think for a second. What's the movie genre of the movie titled King of Comedy? I'm trying to demonstrate that sometimes the text could be ambiguous, but with other inputs, it will be very obvious, which is why we sometimes need a multimodal model. Yeah? Yep. Okay. Does anyone have an answer to this question? Is it comedy? That's a good answer. Any other guesses?
Horror.
Horror. Yes. Romance? Yeah. Huh? Drama? All good guesses. I would say, looking at the three words, King of Comedy, I will probably guess it's a comedy because there's a word comedy in it. But in reality, there is a movie called King of Comedy by Scorsese, which is drama. It's a very dark drama. It makes me cry. But the King of Comedy with director Stephen Chow is comedy. It's very funny. So this is how you could see, even with a very simple input that might seem to lead to one result, with the good enough feature, it will help you correctly categorize the thing that you want to categorize. So now I want to talk about the model. So at first, so DistilBERT, like I described, it's a very well, someone else did all the research, and it's available for download from Hugging Face. It's very easy, off the shelf. You can get all the perks of the pre-trained architecture. You literally just download it and fine-tune it on your data set, and then it works, swell. I also attached a tutorial from Hugging Face and Scorch in the back of this slide, in case you want to play around with it. The cons of it is that it only takes textual input, so the valuable continuous input like price will not be taken as face value. And there's no way to differentiate or highlight different inputs if I have directors or I have, release year, all these informations. When you want to put them in a language model, you have to concatenate all the information into the same input stream, and then send them in. And you kind of just hope for the best. There are ways you could tweak it, you could add separation tokens and all that, but there's not a very definitive way to say, I want to set weights on, directors. I want to set weights on leading actors. And you can only fine tune it, but you have no control over the middle layers. And when you add feature, like I said, you're kind of just messing with the input data. And it works. It's not like it doesn't work. It does work sometimes, but it just won't work as great as if you could just add it to the feature itself. So a custom multimodal DistilBERT, we take the last hidden layer from DistilBERT and still have the access to the contextual information that DistilBERT have to offer. And we combine those with embedded categorical features and continuous features. Now we have the best of both worlds. And it's easy to add new features to your custom layers. Whether you want to add more layers, play around with the dropouts, all the parameters, or just adding new features because it's just one query away. And new input features can be added as is. You don't have to concatenate them into a single text stream. And the cons is you need to build your own, and it's harder to maintain. And it usually takes longer to run because you have to go through all your neural network layers yourself. And here is a picture. This is a very simplified network of what it might look like. This is a multimodal DistilBERT. So, and up there we have the text input, and it goes through the tokenizer to get the tokens like we saw. That's pre-processing. And once we have the tokens, we put it through a DistilBERT and take the last layer, hidden layer of the DistilBERT, run it through some layers to tune it down because it's still on this 68 dimensions of that layer. And then we can add categorical continuous input, do whatever you want and concatenate them into the final layers that you want for your output. This is what it looks like. And yeah, this is just what I said, how you can combine them. And yeah, actually this is the model that you might want to build if you do want to leverage some categorical or continuous features. And now I'm going to share some learnings I learned along the way building this custom model. And the first one is about the CLS token that we saw right here, the CLS token. So when I first built this model, I was thinking we have tokens that goes through DistilBERT, and DistilBERT has many layers, and each token will have 768 dimensions of embeddings of them. So if you have 10 tokens in an input, that's going to be 7,680 dimensions. And that's just way too much. So at first I was thinking, I could just take means of the last layer. So I still get 768 dimensions, but I don't need to get it for all 10 tokens. I only need to take the mean to get one. So that's what I did when I was first building the model. And it kept running out of memory for like a whole week. And I was trying my best to, contain it so it doesn't go out of memory, but it still did a lot. And then I realized that the CLS token that was placed intentionally as the first input token is actually a placeholder token in the design of the model so that it could learn along with the actual inputs in the training process. And then by the end of the training process, it captures all the information that all the other input tokens have. So you don't need to take means or median, max, min, all you want. Just take the CLS token. It is a token that miraculously is representative of all the input tokens for that certain input. So my takeaway here is always refer back to the paper because it is literally placed there for you to have very easy access, and that's why it's called CLS token. It's called the classification token, so that everyone can very easily grasp the information from BERT to do whatever you want, like training on a classifier or so on. And look for up-to-date official guidelines. And I've attached a couple in the end of the slides. And the second learning here, which is the most fun part of building this, is what I showed you just now, that the tokens, categorical input, continuous input, these are all done. Have you taken deep learning? You know how it kind of works? Yeah, you define your layers, and then you define your forward method, which is how your data loader is going to load your data, right? So this is what I showed you. This is how it's done. Is the data loader will take the tokens, the categorical input, continuous input, and they each go through their layers, and then eventually you concatenate it together. But when I was first building the model, I thought, DistilBERT sounds like a hella huge of a thing to put in my model because it still has 68 million parameters despite being distilled. So what I thought was I should get the DistilBERT token outside of my model so that I can keep my model clean. So I'm only taking 768 embeddings from the first part of it. That's all of pre-processing. And I'll just take the last layer along with the other inputs into my forward. That was my thinking. I thought it was very reasonable. But it turned out, again, out of memory for 2 weeks. And in the end, I realized that we do need to put these two models together in the same forward because that's the magic of data loader. Which reminded, I did use data loader in this part, and then another data loader for this part. But when you combine them all together, it is actually much easier for PyTorch, which is what I use, to leverage, because PyTorch looks for tensors and ongoing processes to try to optimize it for you. It's very clever, and I didn't realize that. So putting them together all in the same forward flow provides stable gradient flow because gradients now can account for all the layers, including the ones back in the beginning of this DistilBERT. So the custom model can capture some useful information that is contributing to the overall learning process, which is here. So you can see if I did it this way, which is what I did at first, when you're doing the back propagation, you're only getting it through these custom layers that I built. But if you do it this way, the back propagation will go all the way back inside the 7 layers of very complicated attention layers and all that in DistilBERT. So this way, your model is actually learning a lot more, and the gradient flow is also more efficient because for PyTorch, it's very confusing if you have these models here and these layers here, but they're actually outside of the main process. It still knows that there is some layers, some deep learning layers here. Sometimes they get confused. There are ways to help that process, but it would just be too complicated. And by putting them all in the same forward process, it's also better utilization of computational resources for PyTorch to manage your GPU memory allocation if they're executed within the same computational graph. The takeaway here is to avoid having multiple separate deep learning models running in the same script because PyTorch gets confused. And PyTorch has its way to allocate memory effectively. And keeping the frozen layers in the pre-trained model while not updating the parameters, it's still helping the learning process because the gradients go through them. And the last learning piece was about model deployment framework. At first, I was using Scorch because, like I said, it has a really seamless incorporation with Hugging Face, BERT, some language models in Hugging Face. There's the existing very good tutorial, works great with clean input and output, but there's a lot of wrapper functions around that. So if you're trying to build a custom architecture, it becomes very hairy to try to fit that into a simple architecture. And then I moved on to PyTorch Lightning, which is pretty popular among industry, and it's basically just PyTorch, but it has a clean trainer.train, it trains. Trainer.predict, it predicts. It has a clean pipeline. And the cons is that I personally think the documentation is not always 100% accurate. It could be frustrating for myself sometimes, and the underlying predict method output is nested, which to this day I still don't understand why. But you have to straighten out the output yourself. And then I also considered base PyTorch because it's just PyTorch. You can debug however, wherever you want. The cons is you need to write your whole file just to train or predict these boiler functions that frameworks like Lightning or Scorch would provide for you. After a few backs and forwards, I decided to go with Lightning despite the documentation. I had a bad first impression with Lightning, but in the end I realized it is the most reliable framework for a build to model. And the takeaways here is that develop and experiment with base PyTorch so you can debug, with your embeddings and your shapes. And once the model is built, fit it into Lightning. It's much easier to deploy. And Scorch is really good if you have sklearn pipeline, which means, calculating, logging your metrics with sklearn functions. Because if you use Lightning, sometimes you have to transfer the tensors, back to CPU, back up to GPU and all that. Scorch has a really good streamline of that. I like Scorch, but I can't use it because of the custom model. And Lightning is more broadly used in industry, so it is more transferable as well. And document everything in ADR, which means architectural decision. Damn, I forgot. Record. This is something that people would keep in their GitHub, repo that documents why I chose to use Lightning, why I chose to use Scorch, such and such. So, when one day someone's coming in to work on your project, they know exactly not to try what because you've done it before. So, the conclusion, seriously, why multimodal? Do we need multimodal? Because now that you have your own custom multimodal LLM, you can experiment with any feature you want. You can add layers, you can add cool new papers, like cross network. It's not that new, but you can do whatever you want. And you can add weights to different features, and you can experiment with different model architectures. Like here I use DistilBERT. There's row BERT, DBERT, all kinds of BERT models or non-BERT models you could use. But this also means that you have to do all the research and experimentation yourself. And sometimes managers don't like that. It's just a lot of time that you have to spend maintaining something because you built it, you have to maintain it. And the features, if now we're relying on more features, it means that the features need to be reliable. The data pipelines or the data source cannot be spotty because now your model relies on these features. And at the end, I just want to say to import or not to import, that is the question. Because sometimes it's just like an improv duo or an ensemble. Using a pre-trained LLM and building your custom model are both fun and powerful. It really just depends on who your audience is and what are you trying to achieve. The key is to understand your data and goal and define concrete metrics to work towards. And that's it. Thank you.
Sorry, hi. If there are questions, we have the mic over here. You guys can line up over there. But I saw there was, did you have a question right here? Here, yeah.
Hi, thank you for the presentation. So my practicum is working with LLMs, and we're trying to use them for a regression problem. Do you have any insight on how that would go?
Have you used it? That's my coworker. Have you used LLMs on regression? I would imagine that's it's still just inputs and outputs. So yeah, I don't see any problems with that. I don't work with a lot of regression models, but I would imagine that's deep learning. It shouldn't be too different. Sorry, that's such a lame answer. But because it's all embedded, right? It's dimensions of inputs that you could play with. I hope it goes well. It's gonna work. It's gonna work. Other question?
What was the, oh, here we go.
I can predict my wife.
It's recording.
You talked about including the BERT architecture, DistilBERT architecture inside your model when you're doing a custom architecture. Since you're using a huge model, DistilBERT is huge, so is the compute training, like the compute required to train that worth it to make it more streamlined? And like you said, PyTorch is very finicky when you have the model separate. So do you think it's still possible to have it separate so that you don't have to like retrain the full model every time? Because
Oh, okay, yeah, thanks for asking that. It's not retraining DistilBERT. I don't think my company can afford that. But it's only going through DistilBERT and taking the last hidden layer. It's frozen. The inside layers are frozen. So that's why I said, I thought, we don't even need to use it. But apparently the gradients still want to go through them because it's still a lot of parameters inside. We're not updating the parameters, but we're going through them. We're passing by them.
okay, so only the last hidden layer is being updated. Or
Yeah, we're extracting it as part of the feature. Yeah, so that part is
Thank you.
updated. Thank you. Thanks for asking.
Thank you for the presentation. My question is, if he frees the parameters in DistilBERT, what could be the difference between using just BERT and then DistilBERT? Because sometimes we might need to that 5% performance in the service. Then is it since I'm not sure what is the use case for this service, but is it like inference heavy service so that we need to ensure the inference time should be short? But if it is not, then can we just use like BERT? Because we are not training every parameters in the BERT.
Yeah, that's a really good question. I would say my experience from what I've seen, my friends working in industry, if you don't work for a big company, it's already luxury to have GPUs available for you. And for GPUs, if you're asking for, usually some people work with around, 30 gigabytes memory GPUs. To require for a bigger instance than that could be an issue. But again, if you work with a big company with big resources and they're fine with that, I think that's worth the 5% boost. But yeah, I think if that's not a constraint, for my case, it is a constraint. But yeah, that's something that you have to balance. Thank you.
I have a question, actually, switching gears a little bit. So majority of the students they're about to graduate. They're looking for jobs right now. So I'm interested in your thoughts on how can they best sort of prepare for that process and what, people in your shoes when you're sitting on the other side of the recruitment interview conversation, what they can do to shine in those conversations.
I just want to say, I see my friends, they're my classmates, they're laughing. I wonder what they have to say. Do you have any thoughts on this? Miss? Okay. I think the network is the key, Because, actually, it's a great example because I got my first job through alumni referral through those email chains. And this person here also got her first job through my referral. So yeah, it's just keep close with your classmates. You know, they're on top of all the things. Trust each other, and practice together. And someone's gonna get into a big company, and you can tackle be that person or follow that person. I think the network is very important, at least for me.
Oh, sure, great.
Thank you for the presentation. I know you said that you don't want to expose anything about the company, but I'm just curious, like how many GPUs did you put? Do you use this model at work, and how many?
Oh, I didn't say I use it at work, but I I use a 32 to train. I would say even if it requires less to train, depending on your inference data size, you still might need a lot more if you're predicting on more data than you train on, if that makes sense. So yeah, it's always money.
Yeah, thank you. I have another question. So right now you're looking at like a machine learning engineer, right? What kind of model are you usually building, and how difficult it is, and what the difficulties for you to deploy it?
Oh, that's such a great question. I think I kind of hit it somewhere here. Yeah, it's tough, because do we need a POC or MVP, right? POC, you just want to show that you're smart, like you're capable of using cool stuff. But MVP is something that you can deploy, and everyone can benefit from this new model, whatnot. And we talk a lot about low-hanging fruit in industry. It's not like two VPs or senior directors. They don't care what model you use. They just want to see like metrics going up or down. Like how much money are you making from this new deployment of whatever? It could be role-based, or it could be calling ChatGPT tokens. Like it could be anything. They just want to see the results. So I think to your question, I think part of growing in your career is to identify what's the shortest time it would take you to deliver the maximum impact. And for something like this, this is not usual at all. This is, it's more like a side hobby project because I thought it was fun, so I did it. But no one's gonna appreciate, so what? I just want high accuracy. Like, why are you giving me all this? But yeah, that's it depends on how you want to balance your time.
We appreciate it.
Yeah, I know, that's why I'm Thank you.
So I have some questions related back to job searching.
Mm-hmm.
So you talk about like networking. I wanted to ask what would be the best approach to talk to the alumni or people that we may know, but don't make them feel like we're using them, which is a big question.
Oh, I can talk about myself. I think you should just use them. I think they're really You agree? Yeah, because we were in the same shoes. We were intimidated. Like we feel like we're harassing them. But everyone was in the same, like we want to help, we want to be helped when we needed help. So we are happy to help. I think that's humanity.
So besides networking, what are the other skills or like stats that we need to take on to get a first job?
I think it depends on the area that you're interested in. I would say when I first started, I wasn't so interested in, coding roles, so I never polished the coding skills. But yeah, there's just different things that you need to sharpen on. So if you like coding, go lead code a lot, and you're gonna be fine in that area. But if you like product management, do a lot of products, what do you call that? Case study, like that would help a lot. It's just, yeah, it depends on what type of role you want to step into. Because I think first jobs, it's more about technical assessment. They're not going to ask you too much on like, oh, how are you going to react when such and such happens? Because they're not expecting you to, unless you're interviewing for a senior role. So I think, I could be not entirely right, but I think technical skills are very important, which is what you're learning here, so that's covered. And show enthusiasm.
You're turning on.
Oh. Well, thank you again for the talk. So you got this model and you played around with it and you were able to deploy it. And so it's a categorizing model, right?
Yeah, it's a classification.
Classification model. So what did you, were you just classifying sentences? And I'm curious like what you did with it.
Oh, it's just like categorizing movies.
Oh, okay.
Is it comedy or is it drama? It's one of these things.
Oh, sorry. Hey, thank you for the presentation. And back to the large language model, I'm just curious, why do you choose this DistilBERT model? Because there are so many BERT-based model on Hugging Face, right? Yeah.
I know, this is a constant debate, but to me, DistilBERT is still, like, it focuses on lightness, so it is much faster to download and iterate through. The other ones, they have better performance than BERT. But yeah, I could try them. It's just, yeah, I want this, it's already pretty slow, the development process, so I hoped I could just shorten it a little bit. Thank you.
So when training the model, apart from the text input, how do you choose our feature that you want to add to the model?
Oh, that's a great question. I would say this is business insight. Well, okay, I should say, I think the first thing you should always consider is data reliability, because textual input, you know your data, right? You know what's always gonna be there. If this is an IMDb data set, I'm sure every movie has to have a name, right? If you know your data, there's always gonna be movie names. So, okay, movie name is set. There's always gonna be director names, you can use director names. There's always gonna be, what's gonna be there? There might not be a second support actress or actor. Then maybe put some weights on that feature, or, so for the features that could be super helpful, but they're sparse, take it with a little pinch of salt. But I think that's the first step, to identify what's universally viable, and for your inference set as well, maybe they're new coming data, they might not have everything you had from before. Yeah, take all that into consideration. And and it's just business insights. Your PM will come in to tell you what to try. Just feature experimentation.
Excellent. Okay, if there are no more questions, then let's please thank Siang one more time.
I forgot to show, these are two very useful, I mean, this is bad text, but you can Google it. It's very easy to find. Scorch, transformers, transformer output, tablet data collabs. Good resources online. Thank you.